Tesla Bot Gen 3 launches in Q1 2025 with capabilities no competitor has matched. It operates 14 hours continuously using a 6 kilowatt-hour battery pack, the longest runtime of any humanoid robot on Earth. When power runs low, it automatically docks to a wall-mounted charger without human intervention. Priced at $50,000, Elon Musk projects a 2 to 3 year payback period based on its ability to perform 3,000 distinct tasks. The real question, if Tesla can mass-produce these at smartphone-level scale, what happens to industries built entirely on human labor? The numbers behind that 14-hour runtime reveal something most coverage completely missed. When Tesla first showed Optimus in 2022, it ran on a 2.3 kilowatt-hour LFP battery pack, barely enough to walk across a stage without collapsing. By late 2023, Gen 2 bumped capacity to 2.5 kilowatt-hours, but Musk publicly admitted that version was almost impossible to manufacture. Those viral videos of gold-colored Optimus units folding shirts and sorting blocks? Still using the same 2.5 kilowatt-hour pack. The robots look smarter because Tesla upgraded the AI software, not the battery. Gen 3 changes everything with a 6 kilowatt-hour pack using Tesla's 4680 cells, the same technology in their latest EVs. That's a 140% capacity increase in a single generation, but it comes with a trade-off nobody's discussing. Tesla is now diverting 4,680 cells away from Cybertruck and Model Y production to build robots that don't have a single paying customer yet. Either Musk genuinely believes the humanoid robot market will eclipse automotive within 5 years, or Tesla's making the biggest strategic gamble in its history. The weight reduction matters just as much as the battery upgrade. Gen 2 weighed 138 pounds. Gen 3 drops to 125 pounds. Every pound removed means less energy burned per step, less strain on motors, and critically, more working hours per charge. Physics doesn't negotiate. When Chinese competitor Bang unveiled their iron robot at 176 pounds with similar battery capacity, they guaranteed it would drain faster just staying upright. What makes the self-charging system controversial isn't that it works, it's how Tesla chose to implement it. When Optimus hits low battery, it navigates to a wall-mounted charging dock, extends a connector from its chassis, aligns with precision positioning, and plugs itself in. Once fully charged, it disconnects and resumes work. No human intervention required. But here's what Tesla hasn't explained. The Cybercab uses wireless charging pads and never needs physical contact. Tesla could have given Optimus the same wireless capability, but deliberately chose a hardwired connector instead. The reason comes down to physics and speed. Wireless charging a 6 kilowatt-hour battery generates significant heat in a compact robot body and takes considerably longer. A direct connection delivers higher amperage, faster charging, and doesn't require expensive charging mats installed throughout your home. But this creates a dependency most buyers won't realize until after purchase. Optimus can't charge from a standard wall outlet. It requires Tesla's proprietary charging dock. You're locked into their ecosystem from day one, and if that dock breaks or needs upgrading, you're waiting on Tesla's service network. There's another detail Musk mentioned almost casually during the shareholder meeting that completely changes the use case. Optimus can operate tethered, plug it directly into power, and it runs indefinitely without ever stopping to charge. For factory deployment, that capability is transformative. A tethered Optimus working 3 consecutive shifts could replace 3 human workers with 0 battery degradation concerns and no charging downtime. But tethered operation eliminates mobility, which raises a fundamental question about what Tesla is actually building. Is this a mobile household assistant that occasionally needs charging, or a stationary industrial worker that happens to have legs? The answer determines whether the $50,000 price point makes sense. When Xpeng revealed their Iron robot, they made a deliberate choice Tesla rejected entirely. Iron has synthetic skin, a bionic spine, 60 joints with 200 degrees of freedom, even a feminine silhouette designed to feel less threatening in social environments. It walks so smoothly that half the audience assumed a human was wearing a costume. Xpeng had to cut open the synthetic skin on stage just to prove otherwise. Iron is engineered for emotional connection. It has hair, clothing options, and movements refined to appear more human than machine. Optimus Gen 3 looks like exactly what it is: an industrial tool with legs. Exposed metal chassis, 40 degrees of freedom instead of 200. Top speed capped at 5 miles per hour for safety rather than spectacle. It can deadlift 150 pounds but normally carries just 20 pounds in its arms to minimize workplace accidents. The hands match iron's 22 degrees of freedom, but Tesla spent its engineering budget on grip strength and object manipulation rather than making the whole body move gracefully. No synthetic skin, no hair, no attempt to disguise what it is. The strategic divide reveals two completely different bets on which market matters more. XPeng is targeting retail stores, hotels, tourism, and service industries where a robot's appearance directly impacts customer acceptance. A machine greeting hotel guests or serving drinks at a bar needs to look approachable and non-threatening. Tesla is targeting factories first, then eventually homes, where appearance matters far less than reliability and cost-effectiveness. A robot working around forklifts and heavy machinery doesn't need to look human. It needs to not break when something inevitably goes wrong. XPeng is optimizing for social acceptance. Tesla is optimizing for economic value. Which market is larger probably determines which company wins, but there's a technical detail that might matter more than aesthetics. XPeng plans to power iron with solid-state batteries and 3 proprietary Turing AI chips, technology that sounds impressive but doesn't exist at manufacturing scale yet. Solid-state batteries have been 2 years away for the past decade. Tesla is using proven 4680 cells already in production and the same FSD computer deployed in over 400,000 vehicles globally. XPeng is making bigger promises with unproven supply chains. Tesla is making smaller promises with mature technology. One approach scales predictably. The other might never leave the prototype phase. History suggests which strategy usually wins. The $50,000 price point and the 2 to 3 year payback claim deserve serious scrutiny because the math only works under very specific assumptions. At $50,000 upfront cost, you need to extract roughly $17,000 to $25,000 in annual value to break even in that time frame. A minimum wage worker in the U.S. costs approximately $15,000 per year in direct wages, not including benefits, training, sick days, or turnover costs. So on paper, replacing one employee with Optimus generates immediate savings. But that calculation assumes Optimus actually performs at human-level competence across all 3,000 tasks Tesla claims it can handle. Folding laundry, probably manageable. Cooking a basic meal, possibly with pre-programmed recipes. But what about troubleshooting when ingredients are missing, or adapting when someone rearranges the entire kitchen overnight? Humans improvise constantly using general intelligence. Robots execute programmed behaviors within defined parameters. The gap between 3,000 pre-trained tasks and infinite real-world variability is where this ROI calculation starts falling apart. Tesla did deploy Optimus units at the Tesla diner as bartenders and servers, which proves the concept works in controlled settings. But those robots operate in an environment designed specifically for them. Standardized glassware, consistent lighting, predictable customer interactions, minimal unexpected variables. Your home isn't standardized. Your workplace probably isn't either. The real question isn't whether Optimus can work 14 hours straight. It's whether it can handle 14 hours of unpredictable, non-standardized tasks without constant human supervision and intervention. There's an economic reality early adopters need to understand that Tesla's marketing won't emphasize. Buying Gen 3 in 2025 means paying $50,000 for first-generation hardware that will require software updates, troubleshooting, occasional repairs, and a steep learning curve figuring out what it can and cannot handle reliably. Factor in support costs, downtime, and inevitable bugs, and year one total cost of ownership could easily reach $60,000 to $70,000. But by 2028 or 2029, when Tesla's manufacturing is optimized and the software has matured through millions of real-world deployments, that same robot might cost $20,000 and work flawlessly out of the box with almost zero support needed. Early adopters always pay a premium to be first. The question is whether being first matters enough to justify double or triple the eventual market price. Musk's claim that Tesla will produce Optimus in greater quantities than smartphones sounds aspirational until you examine what that actually requires. Global smartphone production hits roughly 1.4 billion units annually. Even reaching 10% of that volume, 140 million robots per year, would require a manufacturing operation larger than the entire global automotive industry. Tesla currently produces about 2 million vehicles per year across all factories worldwide. A humanoid robot is exponentially more complex than a car. More actuators, more sensors, more precision assembly, more points of potential failure. Scaling to tens of millions of units annually would require building 10 to 20 new gigafactories and securing component supply chains that don't exist at that volume yet. Then Musk drops the truly controversial statement. Optimus will eventually build more Optimus robots. Self-replicating manufacturing where one robot assembles the next, which assembles the next. Growing exponentially without human labor. That's not science fiction. Tesla already uses heavy automation in vehicle production. But if robots build robots, what happens to the 50,000 plus humans currently working in Tesla factories? Musk's answer is they'll transition to higher value work, but he never specifies what that work is when robots can handle everything from assembly to quality control to logistics to maintenance. China isn't sitting idle while Tesla develops this technology. Xpeng, UBTech, and at least a dozen other Chinese manufacturers are all targeting 2026 to 2027 for mass production of competing humanoid robots. If Chinese companies hit manufacturing scale first and price their robots at $20,000 to $30,000 by leveraging lower labor costs and government subsidies, Tesla's $50,000 Gen 3 suddenly looks overpriced in a commoditized market. Does Tesla really have a 2 to 3 year technological lead that justifies the premium? Or will cheaper competition flood the market before Optimus reaches volume production? Musk's statement on X that AI and robots will replace all jobs and working will be optional triggered immediate backlash. But let's focus on what's actually happening right now rather than distant projections. Tesla Diner already replaced human bartenders with Optimus units. Musk confirmed thousands more will deploy inside gigafactories as soon as reliability improves. Those aren't hypothetical future jobs. Those are positions currently filled by Tesla employees whose roles will either transition to robot supervision or disappear entirely. The company frames this as freeing humans from dangerous, repetitive work. Workers might describe it differently. Warehouse operations, food service, elderly care, residential cleaning, these sectors employ hundreds of millions of people globally. A robot that works 24/7 for a $50,000 one-time cost competes directly with human workers earning $15 to $25 per hour. Even if Optimus operates at only 70% of human efficiency, it's still dramatically cheaper over a 5-year lifespan when you account for wages, benefits, and turnover. The math is ruthlessly simple, and it's not theoretical. This is happening in 2025, not 2040. What makes this particularly urgent is the timeline. Gen 3 launches in Q1 2025. If Tesla reaches even modest production volume by late 2026, these robots could be appearing in workplaces at scale within 18 months. Policymakers are still arguing about regulations for self-driving cars, and now they'll need comprehensive frameworks for humanoid robots, potentially displacing 10 to 20% of the global workforce by 2030. We're not ready for that conversation, which means we'll likely repeat the same mistakes we made with social media, allowing the technology to spread widely before understanding its societal impact. So here's the answer to the question we started with. Optimus Gen 3 isn't just another robot prototype. It's Tesla's bet that humanoid robots will outsell cars within a decade. A machine that charges itself, works 14-hour shifts, and costs $50,000 represents the exact moment when robots transition from research projects to actual products you can buy. Q1 2025 isn't far away, but this goes beyond replacing factory workers or household chores. Musk has stated explicitly that Optimus is designed to prepare Mars infrastructure before humans arrive. Self-replicating robots building habitats, mining resources, establishing the foundation for interplanetary civilization. Earth deployment is just the testing ground. What happens in Tesla factories over the next 18 months determines whether humanity gets a workforce capable of colonizing other planets or just an expensive gadget that folds laundry. By mid-2026, we'll know if Tesla beats Chinese competitors to mass production or if cheaper alternatives flood the market first. Either way, the labor market never looks the same. Would you buy Gen 3 at $50,000 now or wait 2 years for the price to drop? Comment below with your take. If this breakdown gave you a clearer picture of what's actually happening with humanoid robots, hit the like button. Subscribe to Tesla Zone and turn on notifications so you don't miss our next deep dive into the technology reshaping our future. The robot revolution isn't coming, it's being assembled right now.